hey, did you miss class today? Did you miss some info today? And you just want to kind of know what we were talking about, get some notes and all that kind of good stuff. We started something new. I'm telling you, Algebra 2, you are going to learn so much math. You're not going to know what to do with yourself. But there is something a little bit new today that we're going to talk about. And so it's called sequences and series. Let's just get on it, okay? So one of the things that we did in class, when you go into Canvas and you pull this up, it should pull up as a PDF. We actually opened it with DocHub, and we're kind of experimenting and playing around with typing in here and typing in our notes as opposed to writing them down. I just really like the format of what I gave you today, and so that's kind of why we did that. I'm going to write it now just for the video purposes. But again, if you want to do this on DocHub and then submit it, you're welcome to do that. The first thing that we're going to talk about, though, is what a sequence is, okay? So a sequence is just a set of numbers with a particular pattern, okay? So with a particular pattern. That's all it is. It's a set of numbers with a particular pattern, okay? Each number that is in the pattern we actually call a term. Okay, so you've seen that word before, but each number that's inside that sequence we actually call it a term. A finite sequence is just a sequence with a limited number of terms. With a specific number of terms, I guess. Let's call it that instead. So with a specific number of terms, okay? And so let me give you an example, right? 1, 2, 3, 4, 5. That is a finite sequence, okay? It's a sequence of numbers. There's a particular pattern to it, and it's got a specific number of terms. An infinite sequence is a sequence with an unlimited number of terms. Okay, so an unlimited number of terms. Basically, it just goes on forever, right? And so, for example, this is when you're going to see the dots, right? So like 0, 1, 2, 3, 4, ... Okay, this, by the way, happens to be the set of whole numbers, okay? When we're looking at specific terms, and because that's what we're going to end up doing, we're going to look at specific terms sometimes in the actual sequence, we need to be able to identify them, okay? And so the first term in a sequence, we do A sub 1. That's what we call it. It's called A sub 1. And then every term after that, we call it A sub n, and n is just the term number that's in the sequence. So for example, in this set of whole numbers, okay, the first term, A sub 1, is 0. A sub 3 would be 2, because the third term in the sequence is this number 2, okay? Let's do another example, right? So this particular pattern or sequence, right? A of 1, so A sub 1, the first term is 1. A sub 4 would be 1, 2, 3, 4, so that's the 13. A sub 9 is in this ... so we just have to go get it and go figure it out, okay? And so when you kind of, find the pattern, I'm adding 4 every time, okay? You're going to end up adding 4 each time, so we're at 21, 25, 29, 33. There's our 9th term, okay? Let's see, 37 would help if I could add. 41, 45, there's the 12th term in the sequence, okay? Sometimes we look at sequences in terms of functions, and so when we do that, right, since each term that's in there is paired with exactly one term number, right, we can call it a function. So the domain is actually the set of term numbers, okay, so the first term, second term, third term, fourth term, that's the domain. And then the range is the set of term values, Okay, in an infinite set, so if you're looking at an infinite sequence or an infinite set, the domain is going to be the set of natural numbers. Okay, and so we're talking about, 1, 2, 3, 4, 5, and on. Obviously, it's an infinite set, so it's going to go on forever. Now, I definitely want to just encourage you not to get super frustrated about any of what we're talking about. I will tell you that all of these words, all of these terms, all of this notation that we're learning, it's just putting a formality to what you've already done. It's putting more of a formality to finding equations of lines, to talking about a pattern of numbers. Again, it's just making things, formalizing a lot of what you've already done. So, for example, right, way back in Algebra 1, you looked at stuff like this and you wrote an equation for the line, the y equals mx plus b type of thing. So again, it's just a way to formalize it, okay? A recursive formula, so if you hear this word, okay, so a recursive formula is actually a rule where one or more of the previous terms are used, okay? So those are used, and they're used to generate the next term, okay? So a recursive formula is where you might use one or more of the previous terms, right? You use them to generate the next term, okay? The Fibonacci sequence, I don't know if you've heard of Fibonacci numbers, such a cool thing, and they show up so many times in nature. But the Fibonacci numbers actually look like this, okay? It's 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on, so forth, okay? And basically what this means and what this looks like and why this is a recursive formula is because you use these two numbers to get the next one. So 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 and 3 is 5. Okay, so you're using those terms. Now this is what the formula looks like, and this is the part that could potentially be a little on the crazy side. But let me show you what it looks like, okay? A sub n, so any number, any term in here, so any given term that is in here, like pretend we're talking about 21, okay? What you do is you take the term before it, so if I'm looking at the number 21, okay, and this is the 1, 2, 3, 4, 5, 6, 7, 8, the 9th term, okay? I'm going to do the 8th term, which is 13, and I'm going to add 2 terms in front of it, the 8, so that 13 plus 8 makes 21. And so this is what it looks like, okay? So again, it's just a way to formalize this particular pattern, okay? All right, let's go do a couple of examples. One of the things that you're going to have to do is actually evaluate and list out the first 5 terms of sequences, okay? And so let's go do this one. So my first term is 14, okay? My second term is using this formula, and this is a recursive one, okay? So it says for the second term, I'm going to do the first term plus 9. Okay, so my second number, my second term is 23. So then when I go to put in a 3 right here, so a sub 3, so the third term is going to be the second term plus 9. 23 plus 9, which is 32. I need the first 5 terms, so I got to keep going. So the next one is going to be 32 plus 9, which is 41. And then the last one is 50. Okay. All right, let's do it again. Example number 2, right? The first term is 6, and my formula says that for any given term, I'm going to do 2 times the 1 in front of it minus 5. Okay, so I'm going to do 2 times 6, which is 12, minus 5 is 7. The next term is going to be 2 times 7 minus 5. 14 minus 5 is 9. 2 times 18 minus 5, 13. 2 times 13 minus 5 is 21. Okay? Sequences and series and recursive formulas. Let's go see what's on the next page. All right, so here's where I personally think it gets pretty hairy. It takes a lot of brain power to do number 5 and number 6. And sometimes, you know, you're just tired, right? And you're just kind of exhausted. But what you do for this one, or for these kind, is that you're actually going to try to write the rule that works for it. So you're actually going to write the a sub n thing, right? So what is any given term in this sequence or series that you see? I will tell you as well that I am not very good at these. So, you know, not totally gonna lie, right? I'm not gonna lie, right? I'm not the best at these. Sometimes my brain is just, I'm just not good and fast sometimes at numbers. But if you can get one every now and again, that's amazing, okay? I will tell you for this one, this is a recursive formula. And it looks like we're going to do, to get 11 from 4, it looks like we're going to do 3 times 4 and subtract 1. Okay, that's going to give me this 11. Let's see if that works for the next one. So do I do 3 times 11, which is 33, and subtract 1? That gives me 32. Yes, so it's definitely looking like it fits. Okay. 3 times 32 is 96, and if I subtract 1, I get 95. So yeah, that's looking pretty good, okay? So how do we write that, right? So you're going to say any term, so a sub n, is equal to the term in front of it times 3. So we're going to do 3 times, whoops, broke my pencil, a sub n minus 1, right? This is the term in front of it, and then we're going to subtract 1. And that is what that formula looks like, okay? See if you can figure out what the formula is for number 6. Speaking of formulas, that is exactly what an explicit formula is, okay? An explicit formula is a rule in which the nth term is defined, okay? The nth term is defined. Now, it doesn't always have to be just for a recursive sequence. It can be for other ones as well, okay? So all of these that you see down here, 7 through 12, again, you're just going to find the first 5 terms, but this is an explicit formula. So if you ever see this word, find the explicit formula, this is the kind of thing that you're going to write down. The explicit formula, the actual rule that will give you any number in the sequence, okay? So let's go find the first 5 terms here. So a of 1, right, is going to be 7 times 1 minus 3, which is negative 2 times 7, so negative 14. A of 2 is going to be 7 times 2 minus 3, so that's negative 7. A of 3 is going to be 7 times 3 minus 3, which is 0, times 7 makes a 0. And then sometimes you get lucky and you can see what the pattern is, and you can kind of finish out the 5 numbers. Okay, so the next one will be 7 and then 14. During class, I kind of gave everybody a little bit of time to see if they could figure out what 8 and 12 is, so you might want to pause the video and see what you get. Down here, for numbers 13, 14, 15, and 16, your goal is to write that rule or write that formula that will actually fit this sequence of numbers. If you can get at least 2 of them, then you're in good shape, okay? If you can get at least 2, you're in good shape. If you can get all 4, you're amazing, okay? I will tell you that this one, for me, came really super fast. This one, I felt like it worked really quickly. And so this one, any given term, is just the square root of that term number. So this is the first term. The square root of 1 is 1. This is the second term, and that's the square root of 2. This is the third term, the square root of 3. This is the square root of 4. Do you see how that kind of works? So this one for me came pretty quickly, but see if you can figure out a couple more of the other ones. When you get done with this, go watch the second video, which is going to do something even newer for you. So I'm super excited about that. Okay?